Welcome to Papa Junk Shop. Well, I got another Battery Tender 50 amp solar charge controller to check out. It's a PWM one. 12, 24, 36, and 48 volts. PWM solar charge controller, MCU controlled 3-stage charging, selectable charging, output voltage, 50 amp automatic load output control with low voltage cutoff and restart, LCD display for operational states, operational timers included for load output, 2 USB 5 volt 3.4 amp outputs, temperature sensor for charge compensation, protection against overvoltage, reverse connection, short circuit, overcurrent and over temperature, common negative ground, the maximum solar panel voltage output 100 volts. And it comes with a user's manual that looks like the Mppt one, mostly safety instructions and how to run the timer. Okay, maximum input voltage 100 volts, maximum input power 12 volts, 50 amps, 750 watts, 24 volts, 50 amps, 1500 watts, 36 volts, 50 amp, 2250 watts, 48 volt, 50 amp, 3000 watts. Maximum output 12 volts, 50 amps. USB output 5 volts, 3.4 amps times 2. Working temperature 14 to 104 Fahrenheit, minus 10 to 40 centigrade. 9.4 inches by 6.7 inches by 2.5. 2-year warning. So we'll get rid of that. Looks like it's got the same case as the Mppt one. So it's going to have the nice heavy terminals in this little door here. And that's for the temperature compensation. LCD screen, control buttons, USB ports, nice big heat sink on the back. There's the temperature sensor. So, usually I hook it up, try her out, and we'll take a look inside. But let's just take a look inside this time first. So give me a minute to get some screws out and I'll turn you back on. Okay, I got the 6 screws out, so we'll flip her over. This front cover should lift off. That's like the Mppt one. Okay, here we go. Now I'm not going to disconnect anything. We're just going to take a look. So this is what we got inside. Looks like we got 4 MOSFETs, probably for the 50 amp control, and this would be over here for the load control. I'm just assuming this stuff now. So looks reasonably well put together. Looks like they got a coating on everything. We got a 80 volt 820 microfarad capacitor there. This thing was good for 100 volt input. That doesn't seem... Okay, this one's 100 volt. 220 microfarads. I would think they'd want to go a little higher than the 100 volt if you're going to have 100 volts coming in, but oh well. There's a little board up here for the control panel and the USB stuff. Alright, I'll throw that back together and we'll hook her up on the bench here. See how well it plays. Be right back. Okay, I got her stuck back together. Well, I built a fuse block. Matter of fact, I built two of them. I built one for the other one too because there isn't any fuses in there. And I know it's got protection for all that stuff, but still, things can go wrong. I still like to have some fuses, so I built this. So I'll get that hooked up there, and we'll hook it up, power supply and the battery, and we can play with it a little bit here, and then I'll take it and hook it up to the solar panel. Okay, got the fuse block mounted. I've got dual fuses for each wire, and they got 15s in, so we got 30 amps total because this is number 10 wire. So, okay, here's the battery positive, which goes right here. Okay, here's the negative. So when I hook that up there, it should come to life. Oh boy. I'm gonna have to get a bigger screwdriver. Okay, here we go. Okay, she lit up. And I've got a couple of 6-volt stationary batteries that are 30 years old on there. Lead acid. I got 12.5 volts. Okay, now I moved my big boy power supply over to the bench, dug it out, and it's got 3 fans in it. It'll make about 30 amps. It's kind of noisy, so it's going to be even more noise than my heat running, so I'm going to try to talk loud so you can hear me. So there we go. Okay. I'm going to turn the voltage down on the power supply. And let's see, this is the negative. This is the positive. Okay, I'm going to slowly turn the voltage up. Okay, there's 6 volts. If it's like the other one, we should see the sun appear over here at around 12 volts or so. There's 8, 9, 10, 11, there's 12. Okay, it did. Just come on. The light's blinking, indicating that the thing is active and ready to go. Up to 12.5. No amps yet on the power supply. There's 13 volts coming in. Still nothing happening. Nope, just started. 13.2. Nope, got back off. Okay, 13.2, I got like 0.4 amps coming out of the power supply. So, okay, I turn it up to, I'm going to go with 14 volts here. There's 14 volts in. The power supply says 4.6 amps. Now I discovered on my other one, and nowhere in the manual does it tell you this, but if I push this, it shows the amps. Okay, so the power supply is showing 4 amps, shows that. Because the battery voltage is coming up. These batteries are old and they don't have the capacity, so they charge easily and discharge easily, which works nice for something like this. So we're up to 14. So I got an inverter hooked on. Let me turn that on. And I'm going to turn on a 250 watt load on the inverter. I'm going to put this on amps. Let's see. Well, I guess we'll see if I hook the inverter on the battery. Okay, there we go. Okay, almost immediately it started up. So we got 13 amps on the power supply, 13 amps there. 15 amps on the power supply, 15 amps there. And we got 17 on the power supply, 18 on the power supply. Okay, it only stays on amps for a short time. So I got 19.7 on the power supply. 20.1 on the power supply. .4 on the power supply. I think we're sort of stabilized here. 20.6 on the power supply, 20 amps there. Okay, I'm going to turn the load off. And it starts dropping off. Okay, we got 14 volts on the power supply and 14 volts on here now. Coming in. Now it changes so quick. I think 3.7 on the power supply. That's what it says here too. Okay, I'm going to turn that load back on. I'm going to turn the power supply off. I'm going to let the now you can see how quick that battery drops. I'm going to let that run for a little bit and we'll come back and we'll max out my power supply and see how this thing acts. So I'll give it a few minutes. Okay. Down to 11.6 and it seems to be holding there pretty good, so I'm going to fire up the power supply again. I'm going to switch this over to amps. So here we go. Minimum. Okay, here we go. Okay, I'm up to on the power supply. Boy, the thing reacted quick too. With 27, 28, 29 amps on the power supply. 28.5. Turning up the power supply a little bit because the battery's coming up, so the amperage is dropping on. First 29 again. So this thing is pretty efficient, I think. Power supply has 10 gauge wires on it. They're probably about 4 foot long, so probably a little bit of loss in there. So I think I kind of like this PWM as far as operation goes. So at 13 volts, 27 amps on the power supply, 26.2. You know, I didn't check to see what this was on, if it was on lead acid or not. Let's see. I think you hold this. Yep, S for standard. So we're good there. Sorry about that. And this is all the settings for the load. Let's see. I don't remember what I push that again. Okay, and then you can change it. Push it again and it goes back. If you hold this, okay, then it goes back to the normal screen. Okay, so if I turn the load off, of course we're dropping down because the battery's coming back up. And like I say, these batteries are old, so they don't, stuff happens quick on them. They don't have much capacity anymore. Let's see what the voltage is. Or 14 volts already. Now this thing is supposed to have 3-stage charging, but it never tells you what voltages any of that stuff happens at, which is kind of disappointing. And you can't change anything. It's all set in stone. Or if you can change it, they ain't saying how. .2. Okay, so it looks like she works pretty decent. So I'm gonna go hook her up for real on the solar panel. See what she acts like there. Okay, this is the one I'm going to take out and put that one in. And we actually have some blue sky today for a change. Right now, this one is making 18 amps. So we'll see how the new one does. Okay, got her installed. Boy, I'm right up against my bus bar here, and I had to interlace it with the legs on the Mppt one. So no matter how much room you think you got, you never have enough. So it used to be plenty of room, now it's not. These are pretty impressive as far as their physical size goes. Well, you need a big heat sink for it to be dependable. So let's turn her on and put it on the amps. We'll watch it. It says minimum. Wow, jumped right to 19 amps. The other one was doing what? 18? And of course the sun is a little bit higher in the sky. Let's see. It's almost noon, a few minutes. And we do have a few little thin clouds. So I'm running about 342 watt load right now. Let's see what. Okay, we got 14.2 volts, it says. But over here, my battery voltage says 13.8. So I noticed the same thing on the other one. It always seems like it says the battery voltage is 14.2. And I realize that we got some losses in the wires, but they're all number 10s. And we got good connections, I'm sure of that. They're soldered and crimped, and so I don't know why that is. Okay, the fan does come on the inverter, so I'll turn the load off, see what happens here. Okay, we're down to about 10 watts now. This went right up to 14.4. We're still at 17 amps. .4. Okay. If some of you watched my other videos, you know that I got the Mppt version in a 30 amp, and I wasn't real impressed with it, but I wanted to give it a second chance, so I did install it. You can see it right next to it there. Hopefully you can see the numbers on each one of them. So this one says 14.2, this one says 14.4. This 10 gauge wire is maybe 6 inches longer. I wouldn't think that that would make much difference. Got 13 amps coming there, and this one's turned down to minimum. So if I turn the solar input off to this one, let's watch this one and see what happens. Battery voltage says 13.4. I think I'm going to have to go turn a load on. Be right back. Alright, that's 350 watt load on it. 340 watt load. Okay, yeah, this come up to 18, 19. 19.8 amps. I'll put this one on amps and I'll turn it back on. Okay, we're up to 20 there. This went to 18 and this one's dropping. Apparently it thinks that the battery's up enough that it's only going to supply the load. So we've got 19 amps there, 7 amps there, that's 26. Wind's making maybe an amp and the water rail's kicking in a couple amps, so yeah, that'd be about right. My meter says I got 28 amps going into the battery, and my inverter's hooked direct on the battery, so I guess stuff seems to be working okay. We'll let her play for a while and keep our eye on it, and I can keep you updated. So if you enjoyed her, give me a thumbs up. If you haven't subscribed, please do. Thanks for watching. See you next time. I was going to make a separate video about this Mppt controller after I installed it, and it's been running for a few days now. I rewired my panels so they're all in series, so I got about 80 volts open circuit, I think. So it's running on the high voltage input, and that seemed to cure where it would just all at once just disconnect itself and start over again. I haven't seen any of that since I did that, so for whatever reason it works better on the higher voltage. Like I say, I'm not sure if this one's got something going on with it or not, but I wanted to give it a chance because they seem like solid built, and I noticed that this one, let's see, it's probably been a half an hour since I made the rest of that video. So this one's running at what, 12 amps? This one's running at 18. This one always seems to make less unless the batteries are really down. So, and I noticed that this heatsink is warm. And this one is, don't feel anything. Of course, this one is a 50 amp one. This is a 30 amp. So I'm not going to make a separate video. So now, I guess we'll call it over. See you next time. I gotta quit fibbing to everybody. It still isn't over. When I looked at the video, I noticed that this light's on solid. Oops. The one over here is flashing. So I looked in the manual, which doesn't tell you much of anything. But it does say solar panel charging LED. It says flashes during charging, turn solid when fully charged. Okay, so that says it's fully charged. Why is it still charging 13 amps then? And it says 13.5 volts. This one says 13.6 volts. It's still blinking. Doesn't say it's fully charged, and it's a volt more. And it's charging 18 amps. So there doesn't seem to be consistency in the settings. I just want to confirm. Okay, that's in standard, which is lead acid. Let's make sure this one is too. Yep. So they're both in standard, so they both should have the same settings. So I'm not sure what's going on with these things. They're nice, but they're not. See you later.